Today we're going to run a simulation on determining the density of an unknown liquid and an unknown solid. And to do that, we're going to be using one of these. This is called a pycnometer, and it's a tiny little graduated flask with a cap that fits nice and snug. And because we're going to be able to determine the precise volume that's held within here, we can determine the density of anything that fits inside it. So the first thing we need to do is to precisely determine the volume. Even though it says 25 milliliters, that's an approximation. So to determine the volume of this, we are going to we're going to fill this with water, and then we're going to determine the mass of the water, and then we're going to use the density and the temperature of the water to determine the volume of the water. Since the volume of the water will completely fill the flask, that will be also the volume of the flask. So, first thing, let's just go ahead and get the mass. So we're going to go on over to the analytical balance. So the mass is 35.449 grams. That is the mass of the flask and its stopper alone. So I filled this flask nearly to the top with water. Now I'm going to want to put the stopper in and do in such a way where some of the water is going to overflow, and that's okay, but the whole point is to make sure that it's completely filled with water and that there's no air bubbles. So I'm going to dry off all the water that's spilled out the sides. And to check and see if you did a good job, if you turn it upside down, and if you don't see any air bubbles, then we did okay. That way we know that the liquid is completely filling the flask. So I'm going to dry this off thoroughly, and then we're going to go weigh it again. All right, so the mass of the pycnometer and the water, 62.921 grams. So remember at the beginning when we took the temperature, and the temperature was 23.3 degrees? Well, if we check our density table, we can figure out the actual density of water at this temperature. So 23 degrees, 23.0, 23.1, 23.2, 23.3. So the density of water at this temperature is 0.997466 grams per milliliter. We're going to use that in our calculation of the volume. So now I need to empty out the flask with water, and I need to pour the unknown liquid in here. But the problem is that there will be water droplets left inside the flask. Even if I do a good job of shaking out the water, there will still be droplets of water in here. And the droplets of water are going to contaminate the pure liquid, the unknown liquid that I put in here. So I've got to be able to get this bone dry. I've got to get all these water droplets out. And I don't have the time to just wait for it to evaporate. So I'm going to do what's called an acetone wash. So I'm going to take a drying agent, acetone, and just squirt a little bit in there. And I'm going to turn the flask and kind of roll the acetone around. And what the acetone is going to do is it's going to attract the water. And when it attracts the water, when I pour out the acetone, it'll help get the rest of the water out of the flask. What I'm doing here is blowing air through the flask because acetone evaporates really easily. This will help get all of the acetone to evaporate out. And since the water was attracted by the acetone, the water is now leaving as well. So by blowing air and getting the evaporation of all the liquids out of here, we now have a completely dry flask. Now I'm going to take my unknown liquid, which here is marked as liquid number 8, and I'm going to pour it so that it pretty much fills up the flask. I'm pouring slowly because I don't want any bubbles. I'm going to pour near the top, leave a little bit of room for that flask topper. And like before, I'm going to put the flask in, or the topper in, so that there's no air bubbles. I'm going to get myself a paper towel. Just help clean up the mess. Now we're going to weigh the flask with the unknown liquid. And it's reading 57.566 grams. So now I have cleaned out our flask, and we're going to get the mass of our unknown solid. So the solid that I'm using here is solid B. I'm going to go ahead and add my solid to the flask. It almost goes up to the top, but that's okay that it doesn't. We don't have to actually fill it all the way up to the top, and you'll see why. I'm going to put the cap on because when we weighed the flask originally, it had the cap. Okay, and the mass with the solid, 140.760. Next, we want to account for all of the volume in the flask when the metal is in there. So to do that, we're going to fill the remainder of the volume with water. And I need to kind of knock it around because there might be bubbles of air hiding between the pieces of metal. And like before, I'm going to insert the cap and try to minimize any bubbles. The water comes out and we dry off the outside really well. And we take another look. Doesn't appear that there are any bubbles. And we're going to weigh it one last time. So this last weighing will be the flask, the metal, and the water.